I will go ahead and do that. Share my screen. And let's visit our playlist. We're starting chapter 2. And we'll do that.
That's a cute little penguin.
Yeah, that's my buddy. We were on the one of the little icebergs in the previous playlist, or the landing page, I think. So he and I just moved over into chapter 2. This is energy enters and leaves the Earth system. So we're thinking about the idea of Earth as a system. So underneath our roadmap, we'll go to our agenda. And you can see I did upload yesterday's video here. So if you missed out on getting those submitted, those couple of activities I believe we did yesterday, then you can check out the video to see how we did it, and can certainly use that as a resource to make sure that you catch up. And let's go ahead and start this slideshow. You can open that if you like, or just sit back and relax. I think we have a bit to go before we actually start our activity. But getting to Amplify from the slideshow is doable. Or if you like, you can go ahead and open up Amplify and move to lesson 2.1 and be ready to do the activity when I start. I like the slide. The artwork is intriguing. I like that idea of that intense sun from above, and we don't really see the sun. We're just seeing the energy that Earth gets from the sun. We determined that both temperatures and energy absorbed by Earth's surface increase when the amount of carbon dioxide or methane in the atmosphere increases. So next, in this chapter, we're going to focus on figuring out why. Why does methane and carbon dioxide do whatever it does? So why do the temperatures on Earth increase when the amount of carbon dioxide or methane or both in the Earth system increases? So why does that happen? These questions are a lot more difficult to answer. Dr. Irene Lee sent a message asking you to investigate how an increase in carbon dioxide could cause increased temperature. So that's our next task. Here's that message from Dr. Lee. The research you have done so far is impressive. The evidence is strong and it supports the claim that increased carbon dioxide or methane in the atmosphere is correlated with climate change and the decrease in ice. This word right here means it matches, okay? The data we saw shows the same trends. So we're going with this idea of matches. They're correlated. To make your explanation stronger, I'd like you to investigate how an increase in carbon dioxide or methane could cause increased temperatures. So how does this happen? These how and why questions are our next tasks. Sorry for the wait, letting students into class. Let's finish off this message from Dr. Lee. Since we already know that energy absorbed by Earth's surface must be increasing, as a climatologist, the next question is how the amount of energy absorbed by a surface can change. I suggest you look at energy entering and exiting the Earth system, and this will bring you closer to understanding what might be causing climate change. Looking forward to learning from your results. She signs it Irene, Dr. Irene Lee. She's the head climatologist of the World Climate Institute. Now, of course, this is a fiction here, but we're playing a role, and that helps us anchor the knowledge that we're learning as we move through this unit on climate change. So let's start our investigation for Dr. Lee. How can the amount of energy absorbed by Earth's surface change? How can that happen? So in the sim, we can see that energy enters and exits the Earth system. Energy arrows come in from the sun and also leave the Earth's atmosphere going toward outer space. You can see those arrows there. You'll see it as we open up the sim in a few slides. If we know something about energy entering and exiting, we can figure out how the energy in the system might change. When we're thinking about energy in the Earth system, what we really care about is the amount of energy absorbed by Earth's surface. Because that's where life exists, is on Earth's surface. I love this video, it's really cool. And this explains the idea so simply. So when we start talking about energy in an Earth system, think of this little bucket with a hole in the bottom and a hole in the top. And you can determine how much goes in the bucket and how much leaves the bucket. So let's watch this video. Whoop. Let me pause, make sure I can share my sound. And we'll continue on.
This is a model for energy in a system. The system is represented by the tank, and the energy is modeled by the orange water flowing through the tank. This top valve allows energy to enter the system, and this bottom valve lets energy exit the system. Right now, both valves are letting the same amount of energy enter and exit. Because of this, the system is stable, meaning the level of the energy in the system is not going up or down. The valves can also change the amount of energy entering and exiting the system. Let's look at two ways we can increase the amount of energy in the system. The first way is to open the top valve so that more energy can enter while keeping the bottom valve the same. We can see that the level of the energy in the system starts to rise. Now both valves have been reset to let the same amount of energy in and out. The second way we can increase the amount of energy in the system is to close down the bottom valve while keeping the top valve unchanged. By closing down the bottom valve, less energy can leave the system. This also makes the amount of energy in the system increase. Now we know two different ways to get the exact same result. Having more enter or having less leave both increase the amount of energy in the system.
I like this picture right here. This is a great one to just put this photograph comparison in your mind. How can we raise the level in this tank? Well, we can make sure that more comes in than leaves. So we have a bigger arrow coming in and a smaller arrow leaving. Or we can have smaller arrow. Oh, hang on a second, more enters. Yeah, than leaves. Or we can have less leaving. and enters. So even though this is smaller, this is even smaller. Let's keep going.
This is a model for
So this key concept that we just saw demonstrated here is the following. And this is on our key concepts on our roadmap. This is key concept number 6. A system can be stable even as something flows into and out of the system. If this balanced flow is disrupted, there may be changes to the system. So this balanced flow was when the water in the tank stayed the same, even though there was water coming in and water leaving. Okay. Now, if there are changes to the system, these can be gaining water in the tank or losing water in the tank. The same can be said for energy, okay? Not water, but energy. So energy can be demonstrated to operate in the same way as this water does in the tank. Now, how can the amount of energy absorbed by Earth's surface change? Well, the video shows that when more energy enters the Earth system than exits, more energy is absorbed by Earth's surface. The energy in Earth's system changes when the energy entering and exiting are not equal. So that's what creates a change. When something becomes different over time. There's stability in the Earth system when energy entering and leaving are the same. And so this idea of stability is also the same idea as equilibrium. When something stays mostly the same over time. Nature prefers this. A change to either the amount of energy entering or exiting the Earth system affects how much energy is absorbed by the surface. We could also say that that word could be true. For instance, if we opened up and let more water into the tank and we closed down the bottom valve and let less water leave, yeah, we're going to fill up that tank pretty quickly. Now we're going to run some tests in the Earth Changing Climate Sim. We'll see what happens when energy entering and exiting the system and when we make specific changes, okay? So we're going to examine the energy entering and exiting as we do certain things. So we'll follow the procedure. So here we have an investigation that follows a procedure. At the top of the screen, we can record that amount of energy entered and exited. These numbers show that the total energy entering from outer space and exiting back during the time that we take a test or we make an observation. So you can see that in this example, the energy entering and the energy exiting is the same energy. You're going to work with a partner if you're working with me. So we'll discuss and record our predictions, and then we're going to run 3 tests. Okay, we're going to not make any changes. Then we're going to increase either carbon dioxide or methane, and then we're going to try increasing the sunlight. So we have an activity down at the bottom is the link at the bottom of this slide. This is what I'll use to open up my Amplify. You can use Amplify in your playlist by clicking on the slideshow, but you can also go in the playlist right here to find another way to get into Amplify. We're in Earth Changing Climate. So if you get into Amplify that direction, then you'll have to know where to go. If you have your slides open, just clicking this link will take us right to this activity. While it's loading though, we'll check back and see what's happening. We're going to make predictions about what will happen to energy entering and exiting the Earth system during each test. Let's go do that. Here we're in activity 3. We have a prediction to make. So in test number 1, no change. If you make no changes, the temperature will stay the same. Predict what will happen to the amount of energy entering and exiting. Well, if we don't make changes, the temperature stays the same. And if the temperature stays the same, that means that the energy doesn't change. Even though energy is coming in from the sunlight, it's also leaving. So the amount of energy entering and exiting will be equal. So those are our predictions. Hang on, there's more. We have to predict test 2. If we increase either carbon dioxide or methane to 500, wow. If we increase carbon dioxide, the temperature will increase. Predict what will happen to the amount of energy entering and exiting. So my prediction here is based on my experience, is that we increased carbon dioxide and we saw in the sim temperature increase. Now, what's creating that from an energy perspective? Okay, so in terms of the amount of energy leaving or entering, we're getting more energy. In that tank model, the model of the water in the tank, more water was coming into the tank than leaving the tank. That's what describes this situation too. We have more energy coming in than leaving, and so we're building more energy. More energy means more temperature. And I think we have a third test to predict. If we increase sunlight, temperature will increase. What will happen to the amount of energy? Well, we will get more energy from the sun. There won't be enough of it to leave if the sun's energy increases. Then this will get us more energy entering than exiting. I'm looking at B, less energy will enter than exit. No, that won't be true. And of course, the last one is telling us that we would be in equilibrium. And if we're changing the amount of sunlight, that won't be equilibrium. Let's see if I got this second one correct. Entering carbon dioxide. Okay. More energy will enter than exit, or less energy will enter than exit. I like A, that's a good choice. We're done with this side. Let's save and continue. And now we have our procedure. So our procedure is having us test these changes. Let's run the sim, but as we return back, let's read our procedure. Make only one change for each test, okay? And you can see that test number 1 says something different. We're not making any change. So when the timer reaches 40, observe the temperature and the energy entered and the energy exited, okay? So let's see from our data table, what are we doing when you made no changes in the sim? And what did you observe about the amount of energy? So we'll have to do some comparison of numbers. And I have a very laggy computer screen. Okay, so let's go and see what happens. Now, no changes made. We run till the timer is 40. And then we compare these two numbers. And that's me having drawn that 15 seconds ago. Okay, so now we have things happening. You can see that the energy entered and the energy exited is staying the same, and that's really nice. Oh, every now and then it switches slightly. But it's running about the same numbers entering and exiting. I see the global average temperature started out at 14, it dropped a little bit, and now it's just a little bit above. And the energy entering and exiting is still, oh, let's stop. There we go, we're at time 41, and the energy entered and the energy exited are exactly the same. So that's one of our tests. When we made no changes in the sim, temperature pretty much stayed the same. Let's go back and make sure by looking at this. And the graph at the very bottom here is something essential when we run these tests, because we have questions like this. Did the temperature stay the same? Well, as it started out, we can pull the time back. We can see it starts right at 14, I believe, yes. So it dropped and rose, but it dropped the same amount that it rose, so it's just pretty much the same temperature. We'll go with that for now. We might go back and change that. Temperature stayed the same. Okay, the amount of energy that entered and exited was exactly equal. So that's good. Now let's take a look at test 2. Now we increase carbon dioxide or methane. Let's increase the carbon dioxide. So we'll hit the reset button and increase carbon dioxide. We'll also turn on the eyeball so that we can see these molecules as we press go. Now, the average temperature starts out at 14 degrees, and we go until the timer. Well, what are we seeing here in the middle? There's a lot of interaction going on, and sometimes there's energy, it looks like it's being absorbed. I think that's what those little donuts in space are indicating, that the energy has hit those carbon dioxide molecules. And sometimes those little donuts seem to emit one of the arrows. We're almost up to 40, and I look at the energy entered and exited, and I see that we have at least 50 more units of energy entering than exiting. And this is definitely a rise in the temperature. So let's go back and get that information. When we increased carbon dioxide in the sim, the temperature definitely increased and more energy entered than exited. I think we have one more. Yes, we're going to increase the sunlight now. So let's hit the reset button. Let's turn the sunlight to high and press play. Now you can see that those numbers all started out where they did before at 0, 14 degrees, and 0 and 0. We run this for 40 units of time. We see the ice has disappeared. That sun is pretty intense. we see the average global temperature continues to rise. And quite a bit of energy entering compared to exiting. So yes, we have, when we increase sunlight, that's increasing our temperature, and it's giving us 370 is greater than 315. So that gives us then the information we needed about the increase in temperature due to sunlight increasing. More energy entered than exited. Let's hand that in, move back to our slide, and follow what it suggests. So we're on slide 20. So we not only recorded the predictions, but we went on to the next page and we did each of the tests. So we tested for carbon dioxide. Now, we did not test for methane for test 2, but we did run all 3 tests and we recorded our results. What did we find out? We found out that if we increase sunlight, that we increase the amount of energy that entered, and so it became more energy entering than exiting. We did hit the hand in button. You probably noticed that when carbon dioxide, methane, or sunlight increases, more energy enters than exits. Now this leads to temperature increasing. Remember that as energy increases, okay, as this gets greater, this gets greater. Temperature increases even, oh, I'm sorry, that word's not in here. Temperature increases if more energy enters than exits. So temperature decreases if less energy enters than exits. So we're up to our 9th key concept, and that is the end of our lessons. So I think we've done a pretty good job here. Let me stop sharing. And I know that next lesson, we have some specific research literature that we need to be reading and discussing. So we'll check in tomorrow with an article on climate changes on Earth in the distant past. And I think we're looking at millions of years ago, so maybe even billions. So that will be an article for tomorrow. That's all the time we need for today. And then stick around if you have questions. Let me go ahead and say goodbye to you guys, because I'm going to hit the pause button on the recording, and have a great day.